This is part of the system control circuit. This is main chip, and this loading signal, this active low, it comes to this bit of circuit here that forms a NOR gate. So this is one input, this loading signal, and then this here, that goes to the cassette down signal from the sensor. That's low when there's a tape in. So when that's low and this is low, this should be high, because what happens, say if this is low, if that's low, you can sort of think of that as being connected to Earth, even though it's not, but it's sort of as if it is. When this is low, current flows through this resistor, through this diode, and this diode here is reverse biased. So this resistor, it pulls the base of this transistor down, and this resistor pulls collector up because it's turned off. So it's that goes high, and then when that's high, that diode's reverse biased, and current flows through here and into the base of that, turning it on. Now this capacitor, this resistor and this diode, I'm not quite sure what their function is in the circuit. This is 12 volts DC that this capacitor is connected to. So at that DC, it's going to be like an open circuit. I'm not sure what exactly it's supposed to do. But this is definitely, that's how this is supposed to behave. So I'll see if we've got a signal from here first, and then follow it through and see if it's going. See if if that's well, if it's doing what it should. Right, so first output of the chip, so it's at 5 volts now. If I press play, it's dropped down. That's right. I mean, it's still trying to load. Let's turn it off. So this, when it's high, I expect that to be at about 1.2. And then to be about 1.6 when it's low. So it's high now, it's at 1.2. And press play. Yeah, it's dropped down as it should. So it's right up to there, and I'll look at the other side of this diode at the base of that transistor. 0.69. that's when it's on. Right, so when that goes low, this should drop. It's not doing. So that's not changing. So I wonder if that diode's leaky or something. Let me check these diodes. This one. That looks right. That's that one going to base. That looks right. What that D26 is. That looks right. They all look right. Let's check these resistors. 61. What's that supposed to be? This one should be 15k. Yep. This one should be 82k. 60.3. 82k. That's only measuring 60.4k. R53. This one. Where is it? Let's see. It's at 47k. Yeah, that's right. They look right apart from that one. Oh, it's measuring right now. Measure it that way, it reads 60. If I measure it that way, it reads 80. Shouldn't even make any difference. $80, $60. That's me measuring it through that. That's the capacitor and the resistor together. I'm measuring there. That's just going to carry on climbing, isn't it? I wonder what this capacitor's doing. Because to my mind, there should be no current there. Like there should be no voltage across that. It should be kind kind of as if that's not connected, because that's going to be reverse biased anyway. At this point, that's the negative terminal of that capacitor. There's 2.5 volts. You turn it on, drops a bit and goes back up again. But that's 0.6, so there's like 1.8 volts across this resistor here. So that'd be, is that keeping it on? Let me measure it when it's 1.71 volts. I wonder if that's what's keeping it turned on, because that surely can't be right. So I wonder if that, something up with that capacitor, if that capacitor's like letting, well, it seems to be letting current through at DC, but I don't really, unless it's that other diode, but that measured alright. Well, I'll change this capacitor and test it again, see what happens. Right, I'll change the capacitor. And what we're at, ah look, see 0. Hang on, it's not turned on. See, I bet it weren't charging up fully. That's dropping right down now. See, I press play. It's loaded. It worked with that capacitor. Yeah, working. So I can move on to the original fault now.